Hi, I am Yasar Arafath. I am here with another maths video for class 10 CBSE students. I welcome all of you to this video. Trigonometry. Welcome back to my YouTube channel. In the last video, we have started the topic trigonometric identities. You can see on the screen very important trigonometric identities. Sin square theta plus cos square theta is equal to 1, 1 plus tan square theta is equal to 6 square theta, and 1 plus cot square theta is equal to cosec square theta. And some other simple identities are also listed in this table. Those who didn't watch previous video, please watch that video. The link to the playlist of chapter 8 Introduction to Trigonometry is given in the description of this video. In this video, we'll discuss some important problems based on this topic, trigonometric identities. This topic is very important and little bit tough. So if you are watching my videos first time, please subscribe my channel, and if you like my video, please don't forget to press the like button and share this video to your friends. Let's move to questions. So the first question is like this. Given that tan A is equal to given that tan A is equal to 1 by root 3. 1 by root 3 is given, and we want to find out other trigonometric ratios or all other ratios. Okay, we have already seen some similar questions before by finding the third side using Pythagoras theorem. So here we thought applying the Pythagoras theorem using this trigonometric ratio, trigonometric relations or trigonometric identities, we can find out all other trigonometric ratios. Okay, so we can start from cot A. What will be cot A?
Root 3.
Root 3. Cot A is simply root 3. So now to get other trigonometric ratio, first we can apply the identity tan square A plus 1 is equal to sec square A. Okay, we have just before we have discussed one identity, 1 plus tan square A is equal to 6 square A. So applying this identity, we can find out 6 square A, right? Here we know tan A, so that tan square A, so we know. So 6 square A we can write using this, right? So how will come? 6 square A is equal to
1 plus 1 by root.
Yes, 1 plus
1 by 3.
1 by root 3. Okay, in next step we can take the square separate. Okay, so 6 square A will be equal to 1 plus tan square A. For tan square A we can substitute here 1 by root 3 square. Okay, so next step we can write 6 square A is equal to 1 plus, how will come this? 1 by root 3 square. So 3 square is simply 3, right? So 1 plus 1 by 3. How will come? 1 by 3.
4 by 3.
4 by 3. Okay, so sec square A is equal to 4 by 3. So what will be sec A? Square root of, right?
2 root 3.
Yes, 2 by root 3 will come. Square root of 4 by 3. In next step we can split roots for numerator and denominator. So square root of 4 will become 2 divided by square root of 3. Okay, so this is for sec A. Sec A is 2 by root 3. Okay, so next one, using sec, I think we can find its reciprocal. Yes, yes. So what will be cos A?
Root 3 by 2.
Root 3 by 2. Root 3 by 2, because they are the reciprocal. Sec and cos are reciprocals. Okay, and now we can apply the tan A is equal to sin by cos. Sin A by cos A. We know tan and we know cos. So applying this, we will get a sin, right? Okay, so how will come? Tan A is 1 by root 3 is equal to sin A. Sin A is, we don't know, we can simply write sin A. Cos A, we simply got here root 3 by 2. Root 3 by 2. So this you can take to left side. So we will get 1 by root 3. 1 by root 3 into root 3 by 2 is equal to sin A, right?
1 by 2.
Yes, 1 by 2. Root 3's can be cancelled. So we'll get a sin A is equal to 1 by 2. Sin A is equal to 1 by 2. So what will be cosec A?
2. 2.
Yes, cosec A will be the reciprocal, so that is 2. So we got all the trigonometric ratios without using Pythagoras theorem. In the beginning of this chapter, we have done some of the similar questions without using identities. Using Pythagoras theorem, you can find out the third side. Then simply from the triangle, we can write out all other identities. So that's another method. Any idea you can apply if it is not mentioned using identities. So I clear my page. Next question almost similar. Question is like this. Express the ratios cos A, tan A, sec A in terms of sin A. Express the ratios, not all either identities, but only 3. We want to express cos A, then tan A, and sec A in terms of sin A. These 3 trigonometric ratios we want to express in terms of sin A. So I think we can start with the cos. How we can express cos A in terms of sin A? We can apply the identity sin square A plus cos square A. Sin square A plus cos square A is equal to 1. We can apply the identity. Okay. So what will be cos square A? Cos square A is equal to 1. Yes,
1 minus sin A square.
1 minus sin square A. You simply take this square, you shift to right side, that will become root, right? So cos A is equal to square root of 1 minus sin square A. So no values are given. So you simply stop here. 1 minus sin square A is the expression of cos A in terms of sin. Okay. So the next one, I think if we got cos, we can write sec, right? So what will be sec A?
1 by root.
1 by sin square A.
Yes, 1 by square root of 1 minus sin square A. Okay, 1 by square root of 1 minus sin square A, because cos A is the reciprocal of sec A. Okay, so next we want to get tan A. Tan A. Which identity you can use here?
Sin by cos equal to
Sin by cos, right? Okay, so tan A is equal to sin A by cos A. Okay, so what is sin A? We have written here sin A. Sin A, we can simply sin A. Okay, sin A simply sin A. Cos A, we have written here square root of 1 minus sin square A. Okay, no need to simplify. Here we can stop. Sin A by root 1 minus sin square A. So we have expressed these 3 trigonometric ratios in terms of sin A. Okay, this is enough. Okay, next question almost similar. Question is like this. Express the trigonometric ratios sin A, sec A, and tan A. Express the trigonometric ratios sin A, sec A, and tan A in terms of cot A. In terms of cot A. Express these trigonometric ratios sin A, sec A, and tan A in terms of cot A. So we can discuss here. So cot A. So I think better we can start from tan A. How we can express tan A in terms of cot A?
1 by cot A.
1 by cot A. Tan A is equal to 1 by cot A. Very simple. Okay. Now we can apply the identity in terms of cot square A. What was the identity? Cot square A plus 1 is equal to cosec square A. This was the identity we discussed. Okay. So from this we can form cosec square A, then taking the reciprocal we can get sin A, right? Okay. So how will be cosec square A here? Cosec A here, take the square root to left. So you'll get cosec A is equal to square root of
Cot A square plus 1.
cot square A plus 1. Okay. So if cosec A is this, then what will be sin A? We don't have to write cosec A here, but we brought here to reach in sin A. So sin A will be equal to 1 by, right? 1 by cot square A plus 1, square root of 1 by square root of cot square A plus 1. Okay, so we wrote 2, tan A we wrote, sin A we wrote in terms of cot A. Now we need sec A. To get sec, either we want to get cos, otherwise we can find out directly sec using the tan. Okay, so how we can do?
1 plus
1
tan
plus
square is equal to
Okay, then we can do the same. 1 plus tan square A is equal to sec square A. So using this identity, we can apply tan A here. So we'll get to 1 plus 1 by cot A square. Okay, cot A square is equal to sec square A. Sec square A. So give the square separate. So 1 plus 1 by cot square A. Cot square A is equal to sec square A. So simply take the square to left, you will get sec is equal to square root of 1 plus 1 by cot square A. This is enough. Okay, so we have expressed given three ratios in terms of cot A.